Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, my wonderful students of Senior 1. I want to take this chance to welcome you again for yet another TV learning session. I'm hoping to be with you for the next 30 minutes, and I believe you are going to enjoy the lesson. We are going to learn a lot together as you learn from me and as I learn from you. My name is Teacher JB, and today I'm going to share with the senior ones, and the subject is physics, and we are still looking at unit number 4, which is about Newton's laws of motion. I hope you remember. And today we are going to look at one of the last concepts in Newton's laws of motion, which is going to be Newton's law of gravitation. A very interesting topic, if you ask me. That is what we are going to be looking at today. And so, before we start, you need to know the very minimum that each one of you should take from this lesson. Okay? So we are going to look at our lesson objectives. By the end of this lesson, you should be able to, everyone, to state Newton's law of gravitation. You should be able to do that. You should also be able to use the formula F equals gm1 m2 over r squared. I think you can see that formula somewhere on the board. We will want to derive that formula together, and we should be able to use that formula to calculate problems related with Newton's law of gravitation. Now, before we move ahead, there are some terms that we need to know. And I am sure you must have seen some of these terms, met some of these terms in subjects like geography. So we are going to look at some of those terms. One of the terms is planet. Okay, planet. I believe you have heard of the planet, the word planet. Now, a planet is a naturally very large body which revolves. To revolve means to move around, which moves around the sun or any other star. If you look at our projector, you will find there is a list of planets, about 9 planets. But recently, if you study your geography, you check your content very well, you'll find Pluto has been removed from the list of planets because it is so small to be termed as a planet. They call it a dwarf planet. Anyway, you'll learn about that in geography. But these are examples of planetary bodies, what we are referring to as planets. Okay, we'll move ahead. Another word that we shall use that may also confuse some students is the word the world or the globe or the earth. In this case, we shall use it to mean the same thing. It is, the world means the earth together with all its countries and its people. Okay? If you combine everything, like you can see on the slide, that is the world. The earth and all the countries and its people. Right. Another word that is important to us here is the solar system. The solar system means a collection of all the planets that keep on orbiting the sun. But it is not only the planets that keep on orbiting the sun. You also have bodies like asteroids, meteoroids, and comets. So when you combine all those, then we come out with what we call the solar system, a very massive body. You will learn that also in your geography. Another word of importance to us here is the universe. Some people also confuse the difference between the universe and the world. The universe is something much bigger than the world. The universe is an endless space. You don't know where it begins. You do not know where it ends. It's an endless space. And so, when you look at this, our slide is showing you the universe. Another word which you can also use for the universe is the cosmos, okay? Consisting of billions and billions of stars, which are just like the sun, like our own sun. A very complex world outside there, right? Okay, some of you will want to become astronauts. If you want to become astronauts, you will understand more about these planetary bodies, but very interesting. I wish I had more time, would have talked more about that, but for today, our interest is not looking at what constitutes the solar system or the universe. Our interest is looking at the law of gravitation, Newton's law of gravitation. So I want to think that you are ready for us to begin Newton's law of universal gravitation. Okay, so let's move to our chart here. Newton's law of universal gravitation. So what I have done here is that I have drawn a sketch of a certain planetary body, which is called a what? Sun. Say it together with me, sun. And then we have got another planetary body here. What do you call that? The Earth. You remember we looked at them on the slides. So you have the sun and the earth. For today, we are going to be dealing with very big figures. And that's why I have my calculator. I've always told you every time you come for a physics lesson, you should have yourself a calculator. Without a calculator, we are going to find manipulating some of these numbers very difficult. So I have my calculator, you better have your own. I will take you through how to press the calculator when you are dealing with these large figures. Because we are dealing with the earth. Can you imagine? The sun, very, very big. I told you if I had time, we'd discuss more about the size of the earth and the sun, but that is not our point today. Okay, so the mass of the sun, we are using letter M1. The mass of the earth, we are using letter M2. And also, we have been very nice to look for the mass of the sun, mass of the earth, and all these other constants here. Because scientists, who are maybe more knowledgeable than you right now, have got a mechanism, a method of determining the mass of even the sun, the mass of the earth. So these are the figures that we have. We shall be sharing them. You don't need to cram them, but for now we need them. That's why I have written them here for you. So M1 is mass of the what? The sun. M2 is mass of the what? The earth. Now, why are we picking those two planetary bodies? It is because Newton's law of gravitation states like this. And I want you to read it together with me, okay? Are you ready to read it together with me? Let's go. 1, 2, 3, let's go. Any two bodies in the universe attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Isn't it a long statement? Yes. But we can understand it. And that's why we are here. Don't worry. We are here to try to make sense of this statement. Okay. So if you have two bodies that are attracting each other, just like this piece of chalk and the earth, these are two bodies, the earth and the piece of chalk. The piece of chalk is very small, but the earth is very big. All of us are standing or sitting or sleeping on the earth. But if I release this piece of chalk, you can observe what will happen. The piece of chalk falls to the earth. What does it mean? The earth is attracting the piece of what? The piece of chalk. And that is what happens between any two bodies that are found in the universe. Be it my calculator and the mouse of a phone, for a computer, or my calculator and this duster. There's a force between them. And so we are saying that force between them is directly proportional to the product of their masses. So what does that mean? In mathematics we say F is proportional, this is a proportionality sign, to M1 times M2. Why are we saying times M2? Because we are talking about the product of their masses. So it is M1 times M2. And what this means is, when I use bigger bodies, if I increase the masses, make the masses bigger, the force will also do what? Increase. Okay? So if I'm having two small bodies like this, the force between these two bodies is going to be a small force. Let us call it F1. If I now use a bigger body, I increase the size of these bodies, then the force between these two will be called F2. But F2 will be greater than F what? 1. That is the meaning of that law. Let's move ahead. That same force is inversely proportional to the square of the distance between the two. Now, if you measure the distance from the center of the sun to the center of the earth, that distance is radius. Let's call it R. Not radius of the earth. We are using this R to refer to the distance from the center of one body to the center of the other body. We are calling it R. Don't confuse it with radius of the earth or radius of the moon. So when they are inversely proportional, it means when I increase the distance, I take the two bodies far away. What happens to the force? The force reduces. That is the meaning of inverse proportion. You take the bodies far away, the force becomes small. If you bring the bodies close, you bring the body close to each other, it means R is very small. And so F is going to be very big. That is what that statement means. So when we combine these two, then we shall have F is proportional to, up there we have M1 times M2. And down, because it is in the denominator, we shall have R squared. And from math, we can say F is equal to, we shall introduce a certain number, a number which does not change, which we refer to it as a constant, times M1 times M2 over R squared. Now, scientists with more advanced knowledge have discovered that this constant F is called G. And we multiply this then by M1 times M2 over R squared. And this is a very wonderful formula which we get from Newton's law of gravitation. Now, what is this G? This G is called, it is right here, universal gravitational constant. Do you see it? G. It means its value does not change. And the universal gravitational constant, the value is 6.67 times 10 to the power negative 11 Newton meter squared per kilogram squared. Now, do we need to cram this value? No. We will always give it to you. Okay? It is a constant, just like pi. So I don't want you to cram it, but we'll give you when we need you to use it. So this is the formula which is very important. And so from this formula also, if we make G the subject, okay, just try to make G the subject by cross-multiplying, we shall find that G is equal to FR squared over MM, M1, M2. I believe you can do that. Very easy. Again, if you want to make R the subject, it is the same thing. Because if you want to make R the subject, let's just do that one, right? Then we shall go to our question. So if I want to make R the subject, remember the formula is here. So this is over 1, right? So what do we do? Cross-multiply. So if we cross-multiply, let me put it here. When we cross-multiply, we shall have FR squared. Okay? F times R squared is equal to 1 times this. So this is equal to G M1 times M what? m2. So what do? We shall divide this side by what? F. We also divide this side by what? F. Doesn't it look easy? Okay, let's move ahead. This F will cross that F. But you can't cross them because there's no F there. So we remain with it. R squared is equal to G m1 m2 over F. That is the value of our R squared. So if I want to get R, I will now get square root on this side. I also get square root on the other side. You must have learned that in primary, didn't you? Okay. So this is going to be the square root of G m1 m2, then divided by what? By F. That is how we make R the subject. And that formula is right here. You can do the same thing, make G the subject. It is also there. That's what you'll find. So look at our lesson objectives. Remember them. We said we have to know how to state. Okay? We said we needed to know how to state Newton's law of gravitation. I think we can now state it. We also need to know how to use the formula F equals G m1 m2 over R squared. That is the last part that we are going to look at right now. Okay? So let's move ahead. Get your calculator, because we are going to press the calculator. Okay? Get your calculator, we are going to press the calculator. In the meantime, let's look at these examples. I may be able to do one together with you. I may leave you with the second one. But let us try. So we are beginning with question number 1, which is here. Question number 1 says, let's read it together. Determine the force of gravitational attraction. Force. Determine the force of gravitational attraction. So what does it mean? They want us to find F. Me, I like to organize my work like that. Determine the force. So they want us to find F. Between a student and the earth. Wow. So you, as a student, there's a force between you and the earth. Can you imagine? The earth attracts you. If you want to prove that, you can climb on top of a small tree maybe. Don't climb so high. Then you can jump at a very low height. You will see that the earth attracts you. All right. The mass of the student is 60 kilograms. So I'm going to say the student's mass is m1, 60 kilograms. It must be in the SI unit, so we're okay there. Let's move ahead. He's standing on the Earth's surface. So this is a student and the Earth. We have two bodies. So let us look at M2. What should M2 be? M2 should be mass of the Earth. Okay? So, have we been given mass of the Earth? Yes, it is right here. Big figure, which is 5.97 times 10 to power 24 kilograms. That is mass of the Earth. Very big. Then, and I remember you studied scientific form in first term. So you are quite okay with those figures. Then let's go ahead. If we want to apply the other formula which we have just derived, this one, to get F, we must know G, we must know M1, M2, and R squared. Okay, so let's go ahead and look at G. What is the value of G? Isn't it what is given here? 6.67 times 10 to power negative what? 11 Newton meter squared per kilogram squared. That is G. Remember, we are looking at this formula. We have G, we have M1. Let's look at M2. M2 is mass of the Earth. Okay, we have got that. Now we are remaining with what? R. R is the distance between the two bodies. Remember, this student is standing here on the surface of the Earth. And we say that distance must go up to the center. So it means the distance between the student who is here, because the student is here on the earth, the distance between the student and the center of the earth is going to be this distance, which is given as radius of the what? Radius of the earth. So for us, that distance, we are going to use r, which is radius of the earth. Look at radius of the earth. 6.38 times 10 to power 6 meters. So that's what we have. So what are we remaining with getting? We are remaining with what? R. I mean F. So let's state the formula. Formula is F is equal to G M1 M2 over R squared. So let us write. I want more space, so let me keep it there. So G is 6.67 times 10 to power negative 11 times M1. You remember what M1 is? Mass of the student. So, times M1, mass of the student, it is 60 kilograms, times M2. Remember, M2 is mass of the earth, 5.97 times 10 to power 24. That is M2. The whole of this is going to be divided by R squared, which is 6.38 times 10 to power 6. But remember, it is R what? R squared. So we have to square this. Okay? We have to square that. Okay, let us see what we get. Now, for me, I like you to do this in stages. So get your calculator so that we don't do it at once. You can do it at once, no problem. So get your calculator. You ready? I'm going to get my calculator also. I will then press. The problem is, how do I press 6.67 times 10 to power negative 11? I'm going to use this button here, exponent. Okay? So I'm going to press 6.67, I hope you have pressed that, times 10 to power negative 11, I just press exponent. You see, exponent is here. Then negative is there. Negative, this is for negative, 11. So that is how I press 6.67 times 10 to power negative 11. Okay? So it is 6.67, then exponent negative 11. Let's go ahead. Times 60, then times 5.97 times 10 to power 24. Again, times 10 to power 24, I will press exponent, then 24. Oh, that's what I get. I'm going to tell you the figure which I'm seeing here, which is 2.389 times 10 to power 16. That is what I have up there. Let's see what we get down. Okay, so you clear your calculator. Down we have 6.38, you see, times 10 to power 6. Times 10 to power 6, I will say exponent 6. Okay? Then square it. Square it, you see? This one with x squared. So I square that answer. What do I get? Here I'm getting 4.07044 times 10 to power 13. So I'm going to divide those two. This one becomes easy. So I have 2.389 exponent 6, 2.389 exponent 16. Okay? Then divide by 4.07044 times 10 to power 13. So exponent 13. Okay? Equals. My answer is 586.9. Remember, we are getting what? Force. And what is the unit of force? The unit of force is the Newton. Okay. So that's what we have. Right. Dealing with big figures. I know that scares some people, but you as a physics student, you should not be scared. Just pressing the calculators. Just remember how we press the calculators for getting big figures and small figures, especially with powers of positive and powers of negative 10. We did that here. And so I will leave you with number 2, which says a communication satellite of mass 300 kilogram orbits, that means goes around the Earth. So they have given you mass of the satellite, okay? They have given mass of the satellite. It orbits the Earth at a height of 35,000 meters, okay? Just try to interpret that. So what that means is, this is the Earth, then you have a satellite here. The distance from you to the satellite, from the Earth to the satellite, is 35,000 meters. But you should also remember that there's a distance to the center of the what? The Earth. We said it is 6.38 times 10 to power 6 meters. So if this is the satellite, and this is the center of the Earth, it means the distance you are going to use, you should add these two. 35,000 plus this. You add them to give you, when you add these two, you are going to get what? R. As easy as that. Then the rest of the things are easy, because here they're saying mass of the Earth is this one, and also radius of the Earth is given, and G is given. Mass of the satellite is also given as 300. So I believe you can use that to find how far the satellite is from the center of the Earth. That is this R here. And also find the force between the Earth and the satellite by applying this formula, okay? You know all the other constants, then you can find the value of F. So, in summary, I want to thank you for being attentive. We have been dealing with quite big numbers, but I know you have followed this. Remember our lesson objective right on the projector here, stating Newton's law of gravitation, okay, and also using the formula. Remember the definitions of the meanings of those planetary bodies, planets, the universe, galaxies, and so on and so forth. It can help you to understand this concept of Newton's law of gravitation. And most importantly, you should never forget this. The equation that relates the force between two bodies, which is F equals G, M1 times M2 over R squared. So I want to thank you for being good students, attentive, and I know you have been taking notes, pressing your calculators. Continue doing that even at the end of this lesson so that you can perfect how to work out those problems. Thank you so much. We'll join you next time. Bye-bye.